everyone. Tonight's lesson is on function tables. We've also called them input-output tables. You may have heard of them before. If you look at the picture right here, there is a table or a chart, and that is a vertical input-output table. Input-output tables can also be horizontal to where the chart looks like this instead of vertical like you're seeing in this picture. You also see the robot. The robot kind of stands for the machine that gives the rules for the table. So let's get started. I like to use the toaster as a great analogy for input-output tables. A toaster has one job. You take a piece of bread, you put it in the toaster, and then out comes toast. It's no longer bread anymore. It's toast. It has one job. It's to heat up bread. Well, input-output tables are similar to the toaster as it has one job. So if I put a 6 inside this machine, and the job of this machine is to add 2, 8 would come out of the machine. So put in 6, add 2, 8 would come out. Now, the rule is written as an equation. So you would have 6 plus 2 equals 8. Now, if I called the input an I and the output, let's say, a T, we would write the equation like this. Anything that was an I would go in, anything that would go in the N, you would add 2 to it, and that would equal the T, or the output. And all input-output rules are written in an equation like this.
We're going to try some examples. So grab that page that you brought home for homework and let's get started with example 1. Our first example is an input-output table that we are going to label the inside with the variable A and the outside with the variable B. So A can have the value of 2, 6, or 8, or anything that you want to put in the input side would have that value. And B would have the value of 8, 12, and 14. This is kind of a clue because it's going to tell us what kind of things that we can actually add to the table to help us find our rule. So let's first start with the 2 and draw an arrow from the 2 to the 8. That's what we're going to start. We're going to find the rule. To help find the rule, we're going to look for 2 things. If the numbers in the in and out sections increase, we will multiply or add. So going from the 2 to the 8, are we increasing or decreasing? Hopefully you're saying increasing because that's what it's doing. So the numbers in the in and out section are increasing. So what operations will we try? Well, only 2 operations will get us increasing. That will be addition or multiplication. Now, you're going to have to try both. So we're going to say 2 plus what number will equal 8 and 2 times what number will equal 8. Well, 2 plus 6 equals 8 and 2 times 4 equal 8. So we have 2 possible rules for our input-output table. The rule can be plus 6 or it could be times 4. Now, let's go look at our next one. We have 6. We're going to 12. So it's increasing because remember, an input-output table only has one rule. So let's try both of the numbers that we showed above. Will plus 6 work? And will times 4 work? Well, 6 plus 6 is 12. That's a check. But 6 times 4, is that 12? No, 6 times 4 equals 24. So that's not correct. So I'm thinking right now the rule is plus 6. So the first time I tried it here with the 2, I was checking out what are my possibilities. My second time, I'm seeing if there's a pattern between the first time and the second time. My third time, I'm going to make sure that I am totally correct. So I'm going to say, is 8 plus 6 going to equal 14? And it does. So my rule I know is this. Add 6. Now, I have to write that in this equation. So I'm going to put my input, because my equation is going to be my input. My rule happens, which is plus 6, and that's going to give me my output. But we know that the input is labeled A. So A plus 6 will equal B. Now, if A equals 5, I would replace this A with a 5. I would add 6 to it, and that would get me my B. So what would B equal? Well, B would equal 11. Okay, that's example number 1. Let's move on to example number 2. Okay, example number 2 is going to be labeled with the variables C and the variables D. So, let's start with the same way. If the numbers in the in and output section are decreasing, we're going to subtract or divide. So let's see. The 12 is going to the 10, which is not increasing, that's decreasing. So there's two operations we're going to try. We're going to try subtraction, or what's another way to decrease a number? You got it, division. So 12 minus 2 would be 10. 12 divided by what number would equal 10 though? Well, 12 divided by 1 is 12. 12 divided by 2 is 6. So division is not possible. So it's got to be minus 2. Let's see if that rule works again. 16 minus 2 equal 14. Does that equal 14? It does. One more time just to make sure. 20 minus 2 equal 18. Yes. So the first set of numbers is going to be giving us an idea of what it might be. The second one, we're going to try that idea, and the third time, we're going to prove. Now, let's write this as a rule. We know the rule is minus 2. So if we take an input number, any number that we put in the input will be a C number. We subtract 2 from that number, and we should get an answer D. So if C equals 5, we would say put C in the place of 5. 5 minus 2 would equal D. What does D equal? D equals 3. Very good. Now, you should be ready to get started on the rest of these problems on your own. You are going to notice that in some of the problems, you are only going to have to write the rule and give what one other variable would be if you were to put in a random number, and the numbers aren't random, we're giving them to you. Another thing that you're going to have is one that you're going to have to actually fill out the table. And then your very last thing you have to do is read a story, a word problem, create your own table, and answer some questions about it. I think you're going to have an easy time with this. Have fun.